Number one, we have a GCF. We can divide both 27 and 72 by 9. X squared is the lowest power, so 9x squared. 27 divided by 9 is 3. X cubed divided by x squared leaves you with x. 72 divided by 9 is 8. Number two, you can divide both 5 and 30 by 5. There's also a k in both. Now I'll show the division this time. So 5 divided by 5 is 1. K to the fourth over k leaves you with k cubed. Remember, that's 4 minus 1. You subtract those exponents. And then 30 divided by 5 is 6. K's are gone. Number 3, you know it's dots. 1, because it says it, but 2, you have 2 perfect squares with a minus sign in between them. So square root of 25 is 5n plus 8, 5n minus 8. Number 4, 3x plus 4, 3x minus 4. Number 5, trinomial factoring. We want 2 numbers that multiply to 56 and add up to 15, 7 and 8. Well, the 8 is negative, so we need 1 plus and 1 minus. Four times 2 is 8, and 4 minus 2 is 2. 4's got to get the plus, so they would add up to that plus 2n in the middle. So 7 factored by grouping, split it down the middle. On this left side, your GCF is 5x squared. 20 divided by 5 is 4. X cubed divided by x squared leaves you with x. 35 divided by 5 is 7. On the right side, we can divide those both by 3. 12 divided by 3, 4. 21 divided by 3 is 7. Those parentheses match. Take them out. What's left over is 5x squared plus 3. Eight, same idea here. We'll divide those both by 8 with a b squared. So 7b plus 6. On the other side, divide that by 7. Take the 7b plus 6 out, and you're left over with 8b squared plus 7. Nine. 7 times 7 is 49. 7 plus 7 is 14. On the bottom, 7 is prime. Only 7 times 1 is 7. And 7 minus 1 is 6. So there we go. One of the m plus 7s on top cancels, and we're left over with m plus 7 over m minus 1. 10. 4 times 1 is 4. 4 plus 1 is 5. All over n plus 4 and n minus 4. The n plus 4's cancel, and you're left with all right. Now, just make sure on the real test you read the instructions. Don't keep doing what we just were. Set the bottom equal to 0 for the undefined. This is just a to the first, so just do opposites. Add 54, divide by 9. 12, though, is a quadratic, has a square variable. And then also don't forget that there's a -1 in front of that p in the middle. We use 4 and 3. The 4 has to have the minus, so they would add up to -1 in the middle. Now we just say p equals 4, or p equals -3. Same idea. It's a quadratic. It's a square equation. It's a square. So we're just going to go with 6 and -2. And that gives us -6, or r equals +2. Number 14, power to a power first. Just don't forget that 3 has a 1, so it's 3 cubed. Power to a power, we multiply. 2 times 3 is 6. Now y also has a 1, so that's 1 times 3 is 3. 3 cubed, you can just type into your calculator. 3 times 3 is 9, times another 3 is 27. Bring down the rest of it. Now, just multiply 4 times 27. You can do that on your calculator. Get 108. We're multiplying the x's, so add those exponents. X to the 9th, y to the 5th. Number 15, we just got to do the distribution. So 2x, add those exponents, 4 minus 6x cubed plus 10x squared. Now I'll distribute the x. That's x cubed minus 3x squared plus 5x. Now I got to distribute 3 plus 3x squared minus 9x plus 15. Now we got to combine our like terms, and there are a lot of them here. I'll just bring down the 2x to the 4th. There's no other x to the 4th. Negative 6x cubed plus 1x cubed, negative 5x cubed. Now there are 3x squared, so just be careful. 10 minus 3 is 7, plus that 3 back, 10. 5x minus 9x, negative 4x. Bring your 15 down. $16. Evaluate each of those functions. So all we do is substitute the number in. Those bars mean absolute value. So first off, -9 minus 3 is -12. The absolute value of -12 is 12. 17, plug the 7 in. You can just type that in, or if you do PEMDAS, you got to multiply, or you add 14 plus 2, 16. Same idea here, just be careful. There's more than one x, so you got to substitute that in more than once. 3 to the third, we said it earlier in this pretest, it's 27. 5 times 3 is 15. Then you subtract, you get 12. You could just type that in. Now 19. First step, swap your variables. Now I have to get x alone, add the 8. Oh, geez, what'd I do there? Sorry, guys, I swapped the x and the 4. Sorry. Swap your variables this time. Jeez, I don't know what's wrong with me. Add the 8. Divide by 4. Now, just don't forget about that -1. That means inverse. 20. Swap them, get y alone, easy, add 4. Done already. Put the -1 on. 21. Remember, when it has the of n, when it has the function part, forget about it at first. Just swap your variables like before. Now I got to get h alone, divide. So n over 4 equals h. Put the -1 on for inverse. Tack back on that function notation. All right. Almost there, guys. 22. 3f minus 2g. Okay, f is x squared plus 4x. I'm going to put parentheses around it, though. (2g) with parentheses again. Now we got to distribute 3x squared plus 12x minus 6x minus 10. 3x squared, 12 minus 6 is 6. Bring the 10. 23, another function operation, but this time it's just h times g. H is a squared plus 3a. G is 3a minus 5. Multiply, so I got to distribute 3a cubed minus 5a squared plus 9a squared minus 15a. -5 plus 9 in that middle is 4. Find f plus g. Well, hey, that's easy. F is x squared minus 5x. G is 3x plus that. There we go. -5 plus 3 minus 2x. Okay. Now, 25 is even to mirror image right down the line. 26 If I take that and I rotate that, it still looks exactly the same. That's odd. 27, if I try to fold that over to y, that reflects back, doesn't line up onto itself. If I rotate that, it's now under there, so that one's neither. Odd, I put the negative in, put the negative x in, figure your signs out, negative x cubed, negative times negative positive. But that third one makes it negative x cubed, so negative 4x cubed. That 3 parentheses negative x changes it to minus 3x. You've shown that the whole thing is opposite. So you have shown it is off. '29. Now, negative x to the 6th. Negative, negative is positive. Then negative, negative, positive. 2 more powers, negative, negative, positive. Negative x to the 6th is the same as positive x to the 6th. So there's no extra negative making it out of those parentheses. That stays. Since there's no extra negative to make that negative 8 change to a positive. Same idea here. Negative x squared is positive x squared, so there's no extra double negative to switch that. 1 doesn't have an x, so I just bring it down. That whole thing is exactly the same. I've shown it's even. Is this a relation to function? Nope. Fails vertical line test. So I'm not even going to answer the next one. Is this relation a function? Yes, it is. There's no way I can connect any parts of that with a vertical line. It can't be done. But the next part, is it a one-to-one? No. Fails the horizontal. 32? Yeah, I can't connect any parts of that line with a vertical line. So yes, it is a function. Is it a one-to-one? Likewise, I mean, there's no way to connect any 2 points of that diagonal line with a horizontal. So yes.